Hi, everyone, and welcome to your next online class. Today, we're going to be talking about reusable rockets and spacecraft. And we were talking about this a few days ago, actually. Monday, the first webinar that we had of this new round of online classes, we were talking about the recent manned space launch that launched from Florida up to the International Space Station. That launch was on a reusable rocket. That wasn't the highlight of the launch. The highlight was getting humans to the space station from American soil for the first time in 9 years. But another small, quiet milestone that happened was it was the first time that humans had launched on a reusable rocket like that. So today we're going to learn a little bit more about reusable rockets and spacecraft. Why are they interesting? Why are they important? What led to this, and see some really cool pictures and videos about it. Hello to everyone who has been able to log in and join already. Let's see, I see some familiar older names and I see some new names, so welcome to everyone. For those of you who are new to these online classes, use the Q&A box to enter any questions that you might have for me or feedback that you want to give. There will be times throughout here that I ask all of you for some input on something. Now, those of you who are returning viewers might be asking, where is Diego? Usually it's me and Diego here talking about space. Diego is not here at the moment. He's off on vacation for part of the summer. So I hope that he gets to see this remotely and is watching. Hi, Diego. I also had someone ask me, where's your helmet? Diego and I always used to start our space webinars with helmets. Well, bad news and good news. Bad news is I have misplaced my helmet. I do not know where it is. Good news is we have the ability to create another helmet, a new helmet. So the first webinar, the first online class that I'm going to do next week, I think on Monday, is a space helmet build. So I would love for you all to join me then. It's great for kids between the ages of, I don't know, like 5 to 12, but I'm not 5, I'm not 12, and I'm gonna make a space helmet. So if you're older than that and you wanna join anyway and make a helmet along with me, I would love for you to join me. And we're gonna make some great art together. Okay. All right, hello. Yeah, lots of people in the Q&A box saying hello. Hi, everyone. Now behind me, you can see this is the Falcon Heavy rocket. We're gonna talk a little bit more about this later in the class today, but it's just a great background. This was one of the most exciting launches I've ever watched. So I wanted that looping in the background there. Okay, let's learn about reusable rockets and spacecraft. So the idea of a reusable rocket, reusable spacecraft, it's been a dream for a really long time. This has always been something that the aerospace community has wanted, even if they didn't think it was possible or realistic. That's exactly what the space shuttle was. The concept of the space shuttle is, let's reuse our stuff. Let's save money by reusing our stuff. The example we gave the other day with Corey and I here was, what if every time you drove to school, or your parents drove you to school, or you got on a school bus and you drove to school, every time you got there, you all had to just hop off the school bus and the school bus crashed. And then you had to get a new school bus for the next trip that you had to do. If you just threw away the car or the truck or the bus or the plane, every time you traveled somewhere and had to build a whole new one for every single trip, it would be super expensive. And not a lot of people would do it. That's how we get to space right now, or at least that's how we got to space for a very long time. The space shuttle was part of that dream of let's reuse it. The space shuttle ended up not fully fulfilling that purpose. It ended up being more expensive than they thought for a lot of different reasons. It was really complicated. It took a lot to keep it working, but it was a step in the right direction. It was proof that you could take okay, so the rockets didn't get reused. The external fuel tank didn't get reused. But the space shuttle got reused many times, dozens of times. And it proved that that was a workable idea. So in 2002, Elon Musk, he's the guy with the maracas there, he founded SpaceX. And this is the first official company photo. It's just some people in an unimpressive office building. But the idea was, let's pull together the ideas. Let's pull together the people that know this industry, that have a lot of experience, and let's give them a new environment to start to develop this. And one of the mottos of Silicon Valley, of the Bay Area, of this like fast moving tech industry is move fast and break things. The idea is you don't need to be super careful. You can take a lot of risks, and sometimes it's going to work, sometimes it doesn't. Elon Musk, was putting a lot of his own money behind this idea of let's make some actually reusable stuff. And it was a close call. The first several rockets did not launch. Their first 3 launches were all failures. The 4th launch, he said afterwards, if that 4th launch didn't succeed, they were done. The company would have to shut down. They would have no money left, no options. But luck was on their side. Skill was on their side. That 4th launch worked. And they were like, whoo, okay, now we can actually, keep working here. We can try to do something. A few years after that, I think, I should have had this maybe 2009, 2010, 2011, something like that. I'm guessing on the date. They had their first Falcon 9 launch. And that's the very first Falcon 9 rocket that you see lifting off from the launch pad there. And he wanted to call it the Falcon 9 because he is a fan of Star Wars. And he loves the Millennium Falcon. Elon Musk in this case. And so he called it the Falcon after the Millennium Falcon. Now, just a quick note here. This entire webinar, not this entire webinar, is about SpaceX. I'm just going to be talking about them a lot because they are the ones that have done the most in the field of renewable rockets, reusable rockets, reusable spacecraft. We're going to talk about some other companies too. Just SpaceX has done more than everyone else. I am a fan of the company, so I'm familiar with it, but this is not an endorsement of them or saying, that they're the only ones. There's a lot of really intelligent people working on this problem in many different companies and in many different governments, and it's led to a lot of development. So it's called the Falcon 9. Falcon, Millennium Falcon, and 9 because it has 9 engines on the bottom of it. You see one, column of flame there, but it's 9 engines all thrusting together. It started with version 1 of the Falcon 9, and it's, looks very basic, but still pretty. And it got to space, and it got the job done. As they continued to develop, every time they made a rocket, every time they launched, they learned more, and they added what they learned to the next versions of the rockets. And you can see it sometimes changes visibly over time. Sometimes the changes are just on the inside. Like here's 2 different versions of the rocket here that, there's not a lot of obvious difference on the outside. And so that's, let's see, version 1.1. Here, this is version 1.2. And then they were changing versions so quickly that they stopped trying to give him new version numbers every single time. Once they finished all the developments, they put all those ideas in one. They call that final version the Falcon 9 Block 5. Why is it called Block 5? I've not been able to get a good answer to that. I've looked around, like, I don't know. That's just what they're calling it. So that's what we'll call it. But you can see some obvious visible differences on the Block 5 here. There's black accents on the white rocket. I just think it looks really cool. Not every launch went 100% perfectly. They had one launch that blew up on the launch pad before it even launched. They weren't even trying to launch it that day. They were just doing tests. Before you launch it, you do all kinds of tests. You add fuel to it and you test the engines. You burn the engines for like a half second or something like that. And then you take all the fuel out. you do all this stuff to make sure it's actually working before you try to launch it. Something went wrong on that day when they were testing the engine. Rocket blew up. Oops. They had one of their rockets blow up on liftoff. After liftoff, about a minute after liftoff, it was going up and pop. There were no humans on it. No one was hurt when that happened, but we lost the rocket and we lost the satellite that they were, oh no, that wasn't a satellite. That was a resupply mission to the space station. And oops, but that can happen in space flight. If you, I don't have the video here with me, but if you go and look up like NASA rocket launch blow up or NASA rocket explosion, you can find these massive videos with just rocket after rocket after rocket blowing up, or, you know, trying to launch a little bit and then it kind of like wobbles and then blows up. We have blown up so many rockets trying to figure out how to do it right. And that's okay. That's what test flights are for. You don't stick humans on them. Move fast, break things, or move slowly and figure out how to do it right. Either way, it takes a lot of trial and error. All right, let me catch up on see if there's any questions here that I'm ignoring. Oh, Moises says it's his birthday today. Happy birthday! Look, there's fireworks. I put fireworks, an entire rocket exploding on the screen for you. Oh, good. So Alette's asking the difference between what is a rocket and what was the space shuttle. So rocket is the lower part of what we're looking at here, the part that has the fuel and stuff that's going to ignite, explode, and thrust that spacecraft up into space. The space shuttle has rockets on it, right? The space shuttle itself, I don't call it a rocket. It's got engines on the bottom that use rocket propulsion. It's the way that the fuel combines and shoots out the back. But it's strapped to a couple of rockets there, and that helps take it up into space. The idea is you want to be able to use it again. You want to use it several times. All right, I'm going to fast forward to where we were here. A few people were late. They're wondering what we're talking about. That's kind of the quick recap right there. What if we didn't have to make a new rocket every single time we go to space? Well, it's not easy to do that. It takes work. And as you can see from these last two photos, it doesn't always succeed. But the good news is that it succeeds far more than it doesn't. You can see this graph here by year. All of the green bars are showing successful launches. The yellow and red and black there, those were failures of different kinds. A couple of them I showed you. One of them blew up on the pad. One of them blew up when it was lifting off. But you can see how many launches have happened successfully and correctly and without anything going wrong. You can see for the 2020, the green are what have already launched successfully, and these blue ones are the ones that are planned for the coming 6 or 7 months of the year. All right. Now, in order to reuse part of that rocket, you need to get it back to Earth. If you launch it up into space and it stays there, you can't use it again. So part of sending it up is figuring out how to make it come back. And the basic idea is really simple, is the rocket launches, takes off, and at a certain point, the top part of it keeps going, but the main lower part, which is what they call the first stage, because that's the first part of it, it detaches, and you can see here it turns around and it comes back and it lands pretty close to where it lifted off. Simple idea, not so simple to do. Otherwise, we would have been doing it a lot over the years. The other idea, so what happens here is you need to, once the rocket detaches, once the first stage detaches from the second stage and from the satellite or the cargo capsule that's going to the space station, it needs to do a couple of things. The first thing it's going to do is it's going to flip around and it's going to fire its engines again. So it's going this way, I'm going to come off a screen share. There we go. It's going this way. So it needs to flip around, fire its engines, and start coming back this way. Good. Now you've turned around, you're heading back home. It's going to turn around once again, and it's going to fire its engines to slow down, and it's going to start dropping down like this, which is good. Then it's just going to fly for a while that way. It's just going to drop. No engines, no nothing. It's just dropping. And then when it gets right down close to the landing pad, it'll fire its engines for a third time, and that is when it's going to land. So if you're going to come all the way back and land where pretty close to where you lifted off, it's going to take 3 burns. You've got your boost back burn, which is what they call it because you're boosting back to where you came from. You've got your entry burn to just help slow everything down, and then your landing burn. The other idea, so that takes 3 extra burns. That takes more fuel. Someone was like, what if we didn't have to bring the first stage all the way back to the landing pad every single time? What if we could take the landing pad to the first stage? So what they did is they figured out they could park a ship off the coast in the Atlantic Ocean, a couple 100 kilometers off the coast, and they could catch that first stage of the rocket. So it launches, it's going like this. The second stage here detaches from the first stage, and the second stage goes flying off on its mission. The first stage just kind of coasts for a while. It doesn't do a boost back burn, doesn't have to do a lot right away. It just goes. And when you throw a ball and it kind of hangs in the air and then it comes down, that's basically what's happening with the first stage of the Falcon 9. As it starts to re-enter the atmosphere a bit, it's going to do an entry burn. So it's going to burn once in order to slow itself down and not burn up in the atmosphere. And then it's going to burn again, a landing burn, and land on the drone ship. Sometimes they will do all 3 burns. Sometimes they'll do a boost back burn in order just slow it down a little bit. And then they'll do an entry burn to slow it down even more. And then a landing burn to land it safely on the ship. Now, you're landing a rocket. It's not safe. It is dangerous. There's a chance that it crashes and explodes. So they didn't want people on the ship. So the ship is a drone ship. It operates by itself. It's called autonomous, meaning that it can operate all by itself. Humans can control it and send instructions in from a safe distance. They can be like 10 miles away. They can be back on shore telling the ship, okay, move here, go here, do that. So they have these drone ships out there, and they called their drone ships, one of them is called Just Read the Instructions, which I think it's kind of a funny name for a ship, but I like it. And the other one is called Of Course I Still Love You. So this is what the drone ship looks like. And this thing is big. I forgot to bring the exact numbers of how big it is, but it's wide. It's really wide, and they did a lot of work on the ship to make it even bigger. I think you could fit several basketball courts on there. You could probably have 4 or 6 basketball games going all at once. But it's still a ship in the middle of the ocean at hundreds of kilometers out to sea. So the fact that the ship knows exactly where to be and the rocket knows exactly where to go, the rocket talks to the ship, and they kind of like figure out how to meet each other out there. And then it lands. Here's a picture of a rocket on a final landing burn, just a few, maybe 20 meters off the ground coming into land there. That's a gorgeous photo. And look, it's coming down right on the bullseye. Amazing. And there's a photo of that rocket after it landed. And that's really incredible. I'm just amazed every time they pull it off. There's another photo there. And you can see on the bottom of the spacecraft, you can see it's burned a bit. That blackness, it wasn't black when it launched there. It's black now because of as the rocket's coming back into the atmosphere and that engine is burning, it's kind of getting soot and smoke onto it. It's gorgeous. Here's a sequence of photos showing one of the times that they brought it all the way back and landed it on land, not on sea. You can see 1, 2, 3. It gets closer and closer. This one on the left there, there's no legs. You can't see the legs yet. The legs are tucked up against the rocket itself in order to make it fly smoother. As it starts getting lower there, here in this picture, you can see the legs have now extended. They kind of drop down, and then there you see it coming in for its final bit of landing there. Here's another photo. This is a time lapse showing, so you can see the path of that the rocket took, and you can see it's not a perfectly straight path. It's kind of wobbling a bit. The computer on this rocket is constantly looking at what's happening, and it's seeing what is the wind doing to it, what's happening around it. It's making these little micro movements and changes, really fine. It takes a lot of very precise work to get it to land perfectly. And there you go. It doesn't always work. Here is a picture from a safe distance where the rocket crashed on the drone ship instead of landing safely. Oops. Here's a GIF of it. It almost made it. It almost made it. It was just kind of sideways, and you can see right before it finally kind of tips over and blows up, you can see there's like bits on the top. You can see white coming out. It uses compressed nitrogen, just a normal gas that you would find in the air, to shoot out of different thrusters on the top in order to try to stabilize it. And you can see it was really trying hard to fix itself at the last moment. So that was one of the early landing attempts. And the first, I don't know, dozen, 15 or something like that, they all crashed. But each time they got a little bit better. They got a little bit closer and learned a little bit more. And eventually they figured out, boom, how to do it. And here's the funny thing, is like, look at the ship. That ship is not still. It's parked there in the ocean. It's not moving. It's not going like 10 miles an hour in that direction or something like that, but it's rocking on the waves and it's getting pushed around. And even with that, the ship and the rocket are able to talk to each other enough that it can land safely. I'm gonna pop back into the Q&A really quick, make sure I'm not ignoring any of you for too long. Oh, someone asked about the ship that crashed. Were there people on that ship? Nope, no people. No one was hurt. It was just the only SpaceX, the only Falcon 9 rockets that have blown up only had cargo. It just had things, no people. And all of these ones coming back to land, there's not even cargo on that. It's just an empty rocket at that point with almost all of its fuel gone. It just saves a little bit of fuel to come in and land. So what does this look like in terms of successes and failures? You can see all the blue parts of the columns there. Those are successful landings on ships. All of the green bits are successful landings on the ground, on land. Red ones are failed attempts to land on the drone ships. Let's see. The black ones, those were just tests. They weren't trying to land it on a ship. The first several times they did this, they didn't even put a ship out there. They just had the rocket and come in and land on the water as if there was a ship there. And they knew it was going to land in the water and then tip over and crash. But that's okay. They were testing. They were testing. And then once they got good enough that they figured they wouldn't blow up a ship every single time, then they would send out, of course, I still love you, or just read the instructions to catch it. And there's plenty of gray bits in each of these years. And those were times that they didn't even try to land the rocket. Sometimes you're launching a really big satellite and you need every bit of fuel in order to get that heavy satellite up into the proper orbit. When that happens, you can't save enough fuel to come back and land your rocket. So sometimes they launch the rocket knowing that they're never going to use it again. It'll burn up in the atmosphere, and that's totally fine. That's how every other rocket launches. That's just normal. But you can see they've gotten better and better at this every single year. and there's still the occasional failure. You can see here in 2020, they've landed once on land. They've landed maybe 10 times at sea. One time they didn't attempt to land it at all, but 2 or 3 times they attempted to land and it actually crashed. That's because they're trying new things. They're trying different things. Because the whole point of bringing a rocket back is to use it again, right? Good news, they are using it again. On June, I think it was June 4th, just recently, just a few weeks ago, they launched a rocket for the 5th time. The same rocket, up and down, 5 times. So they launched it for the 5th time, they brought it back, and it landed on the ocean on one of the drone ships for a 5th time. That's incredible. They got to drive that car 5 times instead of just driving the car once. So because they're pushing their equipment more and more, all of those crashes that happened, those were on not first-time rockets. It was 2nd, 3rd, 4th. And things go wrong. And every time that happens, every time there's a crash, they learn a little bit more and they can make it better. They can make it safer. Here is a time lapse of a rocket launch. And this is gorgeous. And you can see there's the liftoff. And then up there, you can see where that first stage stopped burning. And you can see where the second stage started burning again, and it kind of takes it off. It looks like it's coming down. That's actually not down. That's going farther up into space, starting to orbit the planet. It's going away from us, not down. But you can see here's the first burn for that first stage coming back in, and that's just slowing down so it doesn't burn up in the atmosphere. And then you can see the rocket turns on again down there, comes in for a landing. It's a gorgeous photo. Absolutely gorgeous. Alette is asking, wouldn't the fire burn the landing pad? Yes, the fire does definitely burn very hot. And they build these landing pads to be able to survive that heat. You want to make sure you don't have anything sitting out there. You're not going to leave your laptop or your coffee cup out there. You're not going to leave your truck parked right next to it. There's a lot of really good design and engineering and building work that goes into making these things so that rockets can take off and land without burning up things that aren't meant to be burned up. Jacob asks, what's controlling the ship when it comes back down? Computer program. Really, really good coding. We've probably all been told in school, like, hey, learning how to program computers, learning how to write code is really important. A lot of the best jobs in the world right now require some kind of, coding knowledge or experience. And a lot more of the best jobs that are going to be coming up in the near and distant future, it's going to require more and more knowledge of computers and ability to program and work with those computers and robots and stuff. That's exactly what's happening here. They are able to program in. After it launches and it's up there and the rocket separates and that first stage comes back for a landing, humans are not controlling that with their own hands or their own commands right then. It's all programmed in. And so you really gotta be a good programmer. Have a large team of very good programmers to figure out how to make it do that correctly. And obviously, they do, and it works, and I am super impressed. And Emmett says, why did they make funny names for the ships? I don't know. Maybe my first guess, and this is what I tell my 10-year-old son when he asks about stuff like this, it's because it's cool. It sounds cool. It could be the ship. You can name the ship Smith, or this is the Tiger. We're going to call the ship the Tiger. Those are great names. But I guess they just like the name, Of Course I Still Love You, better than the Tiger or the Enterprise or something like that. And that's okay. That's okay. They're the ones making the rockets, and maybe it's an inside joke. We all have jokes that we have with our friends that if you make that joke, if you say something to your friend with other people around that don't know the history of that joke, they're just going to look at you confused, right? You know, you go to your friend and you're like, hey, butterflies. Hi. And you both have a good laugh. And everyone around you is like, why is he talking about butterflies? Because you and your friend have a very specific story that you shared about butterflies or something. So my guess is that it's kind of an inside joke, or the people that helped design these ships got to name it. All right. So once they figured out how to launch and land the Falcon 9 really, really well, they started coming up with more ideas. How could we get more up into space? And they had the idea, what if we took 3 of the first stages of the Falcon 9 and strapped them together and used that to launch stuff up into space? That's what they did. It took them longer than they expected. They ran into more difficulties than they expected. Those are 3 Falcon 9 first stages, which means that there are 27 engines on that thing. That's a lot. So it took a lot of really challenging engineering work to make that work, but it worked. And they've launched 3 of them. All have been a success. Very impressive. So the cost of a Falcon 9 launch, if you're like, hey, what does it take? You know, I've got my allowance. I've got some money from doing babysitting. Could I buy a rocket to launch something into space? Well, the price for launching a Falcon 9 is $62 million. So I don't know what you charge for babysitting or washing your neighbor's car, but you might need to bump up your prices if you're going to want to buy a Falcon 9 or to hire SpaceX to launch your idea on a Falcon 9 rocket. But for those $62 million, you can get, let's see what it says here, over 50,000 pounds into orbit. That's a lot. The Falcon Heavy, let's say that you want to launch even more. The Falcon Heavy is $90 million, and that would launch over almost 120,000 pounds into low Earth orbit. That's a pretty good price. I know these prices are not something that you and I work with every day. We're not paying $62 million for, you know, a bag of chips at the store. But in the world of spaceflight, these prices are insanely low. It's like going to the store and finding a Snickers bar for 30 cents. If you saw a Snickers bar or a bag of chips for 30 cents at the store, you would think these people were crazy. How do you make any money on that? Well, they figured out how to do it. So the cool thing on the Falcon Heavy also is the whole point is you want to reuse the stuff. You want to bring it back and reuse it. Well, they figured out how to do that for the Falcon Heavy as well. Now that I'm looking at this, this doesn't really communicate as well as I wanted to, but that's okay. Here's the idea, right? You take your Falcon Heavy and this whole thing launches, right? It goes along, and at a certain point, there we go. Yeah, these 2 side boosters, these 2 side cores of the Falcon Heavy, those come off together. They're launching and they go boop, and they come off in unison, and just the center core and the top bit keep going. Those 2 side parts, those 2 side boosters, are going to do the first landing thing that we talked about. They're going to turn around, they're going to fly back to Cape Canaveral in Florida, and they're going to land on land. And then that center core is going to keep flying for another minute or so before it burns the rest of its fuel, most of the rest of its fuel. The top part will separate, and that center core will then land in the ocean on one of the drone ships. The first time that they attempted this, SpaceX was very honest about it. They said, you know what? We're hoping to land these things, but we know that there's a really good chance that we're not going to be able to land them. Or if we are, something will go wrong. It's a test. It's a test flight. Everyone's safe. Let's see if we can do it. It's kind of crazy. Let's try it. And they tried it. And those two side boosters came back and they landed together almost simultaneously right next to each other back in Cape Canaveral, less than a mile from where they had launched just a couple minutes before. That's incredible. I watched that happen in 2000. When was that? It was just a few years ago, 2017, 2018, something like that. I watched that happen. I'm like, this is what I thought spaceflight would look like. This is what I thought rockets were supposed to fly like. You take off, you land back on the launch pad. That's what we saw in the movies, right? That's what I saw in cartoons growing up. And now we finally got to see it in real life. That center core then kept flying and it tried to land on the drone ship out there and it did not. That's okay. They figured out what happened. They had kind of miscalculated on the fuel. There wasn't enough fuel left in it to slow it down enough. So it made a nice soft landing at 300 miles an hour. The good news also is that it missed the ship. When it saw that it wasn't going to be able to land safely on the ship, it kind of moved off and it landed just off to the side of the ship in the water instead of crashing on the ship and probably damaging it quite a lot. So I was talking a couple minutes ago about the cost, right? It cost $62 million to launch a Falcon 9. It cost $90 million to launch a Falcon Heavy. But what you're looking at, what you're looking for is how much does it cost per pound to send something into space? And that's why I made a point of talking about what does it cost? Like how many pounds can it get up? When we were talking about the space shuttle 2 days ago in one of our earlier classes, the space shuttle was able to bring up, I think I have it here actually. All right, well, not exactly, but the space shuttle was able to bring a lot of stuff up into space, but the Falcon Heavy can launch more to space than the space shuttle could. It could take a heavier satellite to space, or it could launch a heavier piece of the International Space Station than the space shuttle could. So what you're looking at is what is the cost per pound or the cost per kilogram to send something into space. The first space shuttle that launched in 1981, it cost $85,000 per kilogram to get something into space. That's a lot of money. The space shuttle in 1995, they had improved and learned enough that they had brought the cost way down to 26,000 pounds per kilogram to get something into space. The Falcon 1, which was the very first version of rocket that SpaceX had, it was just under $10,000 per kilogram. There's another rocket that's used a lot right now. It's called the Atlas V. Great rocket, and it can launch for about $5,500 per kilogram. Well, if you're doing the math, or if you are looking at this slide and looking ahead of where I'm pointing, you can see here's the Falcon 9, $1,891 per kilogram to get something up into orbit, compared to, $85,000 on the first space shuttle. And you look at the Falcon Heavy, it's less than $1,000 per kilogram to get something into space. That is almost 100 times cheaper than the very first space shuttle. That's an incredible leap in technology. That's an incredible reduction of cost. And you can see recently the cost for spaceflight has been going down, down, down. One of SpaceX's goals is to get the cost under $100 per kilogram to get something into space. And I think that they're on a good track for that. If that's their goal, they're heading the right direction. Good. Oh, Gunbeer asked, why did they name rockets and then put 1, 2, 3 after it? Okay, so I explained earlier, and perhaps you join us after this, they call it the Falcon 9 because there's 9 engines on the bottom. So So the Falcon 1, they called it Falcon 1 because it only had one engine on the bottom. Falcon 9 has nine engines. The Atlas 5, I actually don't know. Maybe the Atlas 5 has 5 engines. That's a good question. Or maybe it's just the 5th version of an Atlas rocket that they made. And Ranbir says $62 million. That's so cheap, with a winky face. Yep. All right, Ranbir, I'll watch for your rocket launch. I'll be cheering for you. Jacob asks, how many rockets were made? So I don't know how many Falcon 9 rockets SpaceX has made, but I do know that they have launched 80 rockets, or they have launched 80 times. And since they're reusing many of their rockets, they've made less than 80 rockets. 2 of those rockets didn't make it. So that's still a pretty good success rate, especially looking at when's the last time they had a failed rocket launch of any kind. Going back here, back. Wow, put a lot of slides in here today. It's been 4 years since something went wrong on one of their launches that made it so that it didn't work. It's pretty great. All right, fast forwarding here to the end, just a couple more things to go over before we wrap up for the day. So SpaceX has their next thing in mind. Here is the Falcon 9 rocket as it exists today. It's a massive rocket. It's huge, but not compared to these other ones here. On the left, you see the Saturn V rocket. This is the rocket that launched the Apollo missions to the moon. Outstanding piece of equipment. Outstanding rocket. This is the next idea that SpaceX has. They're very much working on this right now. And they call this the Starship. And you can see it's bigger than the Atlas V. Bigger than the Saturn V, way bigger than the Falcon 9. And it's actually a much heavier ship than the Falcon Heavy. And you would think, wait, we're trying to get stuff to space. James, didn't you say on Wednesday that the reason they don't paint the external fuel tank on the space shuttle white anymore is to save the weight of the paint? That's right. But what's going to go into building this spacecraft, even though it's going to be quite a bit heavier than what is normally launched, is it's a much stronger material. It's a very specific kind of metal that is very strong, and it's great at absorbing the heat of space flight and stuff like that. But also it's super cheap. It's just steel made in a certain way. It's super cheap to get it, super cheap to build it. And if they do it right, the cost of everything to make it is going to go way down. And the goal is that they're able to reuse that 100 times. The goal of the Falcon 9 is to be able to reuse the Falcon 9 10 times. And as we covered, they've already launched and landed one of them 5 times. So they're making good progress. They want to be able to launch one of these 100 times before they have to retire it. That was the idea with the space shuttle. You know, one of the early numbers thrown around with the space shuttle is like, we want to be able to launch this thing 50 times a year, use it for a few years, and then retire it. That's not what ended up happening. They were only able to launch each space shuttle, 4 or 5 times a year. They ended up using it for 30 years. That led to a lot of problems. The older something is, the more chance you have to break it. So that's what's coming next. But as I said, SpaceX is not the only company that's working on this. This is Virgin Galactic, and they have a 2-part plane and rocket combination that gets them up to space. This first bit here, you can see this. There's these wide wings here, and there's 2 parts of the plane. This middle part, that's attached on the bottom. So this thing takes off like a plane. Those are jet engines on the front. It takes off from the ground, from the runway, flies up to like 50,000 feet. And then the center thing, that's actually the spacecraft there. It detaches, it drops, and it's got a rocket engine in the back, and it fires that, and it goes flying up into space and comes back down. It doesn't stay up there long, but it goes to the edge of space. You get to be weightless for a little bit. Right now, you can pay to go on those. There's not a lot of these flights happening. They're still testing. They're still perfecting it. But several people have paid, I think it was $100,000, if I recall correctly, to go up into space just for a few minutes. The other company that's working is Blue Origin. Blue Origin is owned by Jeff Bezos. He's the guy that owns Amazon. And he's the wealthiest person in the world right now. He's not just sitting on that money. He's taking a lot of the money that he's making from Amazon and he's investing it in Blue Origin. And a lot of the stuff that Blue Origin is doing is very, very similar to SpaceX. The idea is there's these reusable rockets. Every plan that you see from Blue Origin looks similar to SpaceX. I don't have a problem with that. I think it's a great idea. Who says that SpaceX is going to be able to do it best or that SpaceX is able to do it better? They're the best right now. They're doing it better than everyone else right now. But guess what? That wasn't always the case. In the late 2000s, they had not launched a single spacecraft. It was all NASA. It was all Russia. It was only governments that were doing it. And they came in and they challenged it and they figured a way to do it better, safer, cheaper, way quicker. There we go. So it could be that SpaceX continues to lead this new space race that we're in right now. Or it could be that Blue Origin figures out how to do it better, safer, cheaper, faster, more efficiently. And they beat out SpaceX. I think they would both keep operating, but it's a constant race. I don't have a problem that there's iPhones and Androids. I think it leads to better products for all of us because they're constantly trying to be better than the other guy. If that's what we have when it comes to reusable rockets, reusable spacecraft, I'm a fan. Blue Origin, you can see they're planning big. This is a big rocket here. Compare that to the Falcon 9 and the Falcon Heavy over here. Compare that to the Saturn V. You know, you could use that rocket to get equipment to the moon. You could use that rocket to get equipment to Mars. And then you could use these rockets again. Save a lot of money, save a lot of time. That's good stuff. This is where the dream of reusable spacecraft first really saw the light of day. We've come a long way since then. That launch cost $89,000 per kilogram for what it sent to space. Compare it to this, which was under $1,000 per kilogram to get it into space. We've come a long way. You might think, oh no, I have missed many of the most exciting developments in the history of spaceflight and humankind. Well, guess what? You are going to witness in your lifetime more amazing stuff than what I've covered here. More amazing stuff than what I've covered in all of my space webinars. That's coming up. And the people that are going to do it might be watching this webinar right now. They might be in school right now, or college, or just getting into the workforce. These stories are not the stories of companies. These stories are not the stories of governments. They're the stories of individuals, people who had an idea and they figured out, let's try it. The worst that could happen is I blow up a rocket, and it's led us to some great things. Let's see if I have anything left here to go over. All right. A big thank you to heronbooks.com. A lot of the material that you see in these online classes is directly from Heron Books, even if it's not, even if I'm putting together some stuff separately, like I do with my space science webinars. My work and these online classes are heavily influenced by the curriculum at heronbooks.com, making sure that you understand the words that you're reading or hearing, making sure that you're going on the right grading, not going too fast, not getting into something too deep. I highly recommend, if you haven't, go to heronbooks.com, find some things that interest you and use some of their curriculum. There's a few free packets on there as well. Check it out. All right, thanks so much for coming. I'll see you on Monday when we're making space helmets. I don't care what your age is. If you're 18, let's make a space helmet together. If you're 5, let's make a space helmet. If you're older than that, join us too. All right, see you then.